equation. That is, we have 5e power 5x, and this equals 62. So first, I'm going to divide both sides by 5. So when I do that, I get 5e power 5x. This is divided by 5, and this equals 62 over 5. So we cancel these two fives, and on the left side, we get e raised to the power of 5x, and this equals 62 over 5. And now I'm going to use this exponential form, that is e raised to the power of y equals x, and this implies this can be written as natural logarithm of x equals y. So this is basically the relation between logarithm and exponential functions. So first, let's identify the x and y's. As we can see here, this power is the y. So we can say that this quantity is y, and then this quantity is x, the quantity on the right side. So this is 62 over 5 equals this is x. And this means we can write down this exponential equation in the logarithm form as like this. That is natural logarithm of x. X is 62 over 5, and this equals y. Y is 5x. So now we got the relation for 5x. So we divide both sides by 5 so that we can solve for x. We can cancel this 5 and 5. So we get natural logarithm of 62 over 5, and this divided by 5. This equals 5x. Now we can plug this expression into the calculator. That is natural logarithm of 62 over 5, and then divide by 5, and this equals x. So when you plug this into the calculator, we approximately get 62.143. We get x approximately equals 62.143. I'm sorry, I actually gave the wrong number. This is not 62.43. So it is at x approximately 0.504, and this is rounded to 3 decimal places. We now solve this equation, that is log 5x to the base 5 equals 4. This is the logarithmic equation, and here I'm going to use this relation between logarithm and exponential function. That is, if we have log x to the base p equals y, and this can be written in exponential form as b raised to the power of y equals x. So first, let's identify the x, y, and b. So b is basically the base. So this quantity is b. So that is b equals 5. And then the x represent this quantity. So we say that x is basically equals 5x, and y, this quantity is y. So we see that y equals 4. So now I'm going to use this exponential form, that is b raised to the power of y equals x. So here b is 5. So 5 raised to the power of y is 4, and this equals x. X is this 5x. So we can solve for x from this. Let's divide both sides by 5 so that we can solve for x. So we have 5 raised to the power of 5 divided by 5, and this equals 5x divided by 5. We cancel this 5, and this gives we have x on the right side. And here we can use the exponential rule. That is, if we have a raised to the power of m divided by a raised to the power of n, we see that the bases are the same. That is, we have the base as a uh, in the numerator as well as in the denominator. Only the powers are different. That means this equals a raised to the power of m minus n. This is the rule, and when we use this rule, we just have to subtract the powers. That is 5 raised to the power of, the power here is 4 and the power here is 1. So 4 minus 1 is 3. So we have this value for x. X basically equals 5 power 3, which is 5 cube, and this equals 5 multiplied with itself 3 times. That is 5 times 5 times 5 times, which equals 125. So we found the value of x, which equals 125.